analysis with Autopsy. And I have a memory image I made years ago from, I think, a Windows XP machine or something, so that'll work. Yeah?
Why do you need to install 7-zip when you can extract?
Because this is compressed with 7-zip, the .7z extension.
Windows Explorer doesn't do that?
Yeah, Windows Explorer cannot unzip 7-zip files. It can only unzip zip files. They're adding a couple more things to it in the latest version of Windows 11, like RAR, but you have to add 7-zip to unpack it. Yeah?
What is the username and password to get it on this?
CNIT, CNIT. CNIT, CNIT, and CNIT. Good? All lowercase. There you go. Good. All right. So this is a 7-zip encrypted file, so you have to have this 7-zip utility installed to open it, which I have on this machine. So then you can right-click, and there should be a 7-zip option. Windows 7 always hides all the good stuff because Microsoft loves to be very annoying. So 7-zip, extract here. That should do, and there it goes. Although, to be fair, what Microsoft would say is they changed the rules in Windows 11, and this program was written for earlier versions of Windows, so it doesn't put that shortcut in the right place. That's what happened. Microsoft is constantly changing the rules, and the developers can't keep up. So here's a memdump file that is 500 megabytes big. So it's a machine running with 512 megabytes of RAM, and that's got an image of its memory. Now, I used to use, I think, Memorize, and there was another tool that I used. There was a command line tool that was hard to use, but Autopsy has built it into Autopsy. That's why I say this class has gotten much easier than it used to be. Pretty much you have one universal tool for everything. So you run Autopsy, and I think I need to, okay, first I have to enable the experimental module to analyze memory. So it's Tools Plugins Installed. So here's Autopsy, and I'll go Tools. I guess I need to create a case first before I can get to the Tools menu. So I'll create a case for F210. And just call it F210, and I don't really care about any of the rest of this right now. Okay. And now maybe I can get to the Tools menu. I guess not until this is done will it let me do that. All right. Okay, you could just close that welcome box, would be another way to get to the menu. All right. But I'll let this go and see. I may have to restart Autopsy after turning on this option, but I might already have the option on from last semester. We're going to see. All right. Not letting me in the menu yet. Okay, can I get there now? Nope, still okay. I got to cancel this to get to the menu. All right, so Tools, Plugins, and I think Available. No, Tools, Plugins, Installed, Experimental. Okay, Installed, and one of the, there it is, Experimental. You have to check Experimental to get these optional plugins, and then Activate. Apparently this is already activated. Let's see. All right, I think I've already activated this one on this Autopsy. I'll just close this. And now I'll create my case, which I thought I've done, but I may have to do it again. Now I can add a data source. Okay, I just have to import the memory image. So it's going to be memory image volatility. So add data source. Okay, here we go. The name can be some kind of default name. Okay, here I should find memory image. There it is. Memory image is one of my options. And volatility is that command line tool I described that's hard to use, which is now built into Autopsy. So, and here's what it can do. This tool can do all kinds of things, dozens of things. These are things it can extract from a memory image, and each one of these takes time, so it's best if you only check the ones you need. which I've already done here. These are the only ones I'm going to use. These are things you can find in a memory image. Consoles are command line commands. Hash dump and LSA dump lets you get password hashes. NetScan gives you network information. This gives you running processes. Shell bags give you a record of information about every window that has been opened and where it was. And user assist has information about recently used programs and files. So if you check just them, that will speed it up. And it looks like I've got just those checked in my list here. And then you can also run them all if you're not in a hurry. And then, so I've selected them. And, oh, I need to give it the data. Okay, browse, downloads, memdump, there it is. Okay, now I can do next. And to configure ingest, yeah, just leave it all checked, I guess, and hit next. All right. And it's going to start analyzing. All right, and then you can just find a lot of stuff here. So it might take a couple of minutes to do the analysis. I tried to use a small memory image, but it's not that small. It's half a gig. And these days, of course, most machines have like 4 gigs, so it would be even bigger. All right, and it is supposedly running module consoles. Okay, here it is, running various modules. It's running consoles to find command line commands in the memory, and then it's going to run each of those other things to find other things there. All right, it's 10:30. I'm going to go see if somebody is trying to get in. And I'll be back. That has to run anyway. Okay, nobody out there? And there it goes. Now it's running shell bags. It's going to run each of those modules, hunting through the memory, finding the evidence of all these different activities. Yeah.
How do you create the memdump file?
You can get it with FTK Imager. And there are other tools, but FTK Imager will work. Yeah. You're asking how to create the memdump. Your FTK Imager, you can image a hard drive or folders or memory. Yeah. And of course, that means the FTK Imager executable will be in that memory image. Like I say, you are modifying the data while you measure it, which is, a thing to be aware of. One thing you will find in your forensic analysis is your forensic tools. The only case where you don't have that is when you image an unpowered hard drive, you power it up and connect a write blocker. Then you can actually get pure evidence that doesn't include anything from the examiner. That's why that was the original forensics and people loved it. But any image of memory requires you to run software on that machine, and therefore you change it to some extent while measuring it. So the process is not perfect.
What would you do if you got like a floppy disk or something?
What's that?
What would you do if you got like a floppy disk or something?
What about a floppy disk?
You're trying to like image it.
Oh, yeah, if you have some kind of storage medium, then you could, in principle, image that through a write blocker. And then you get floppy or USB drive or hard drive, you can image them through a write blocker without making any changes. But there's no way to measure RAM without changing it. Although to be fair, there is one way. You could freeze it and then take it to another machine or something, but I'm not aware of anybody that does that. Everybody just accepts that you make some changes in it while measuring it. All right, so I'm trying to finish. It should be done. There. And now it's starting some ingest down here, but we're probably already going to see some stuff. So we go to the memdump module output. Okay, now let's see. Data sources, memdump, module output. And here's the output of these various things. So here's consoles. And so here's hash dumps. All right, there's various things here that you can find in there. And so you'll find some flags here. If you go to consoles, there will be, you can see command line commands that were executed. So let's try that. If I go to consoles, then here I see net user, your name, super secret ad. Here's somebody creating a user account. You just see a variety of command lines going on here. This shows you things that were done in the command line. I wonder if I can scroll in a more controlled way. Over here. There we are. So here's some VMware thing. Here's there. Here's net user Waldo QWERTY. And a command was rejected. The username could not be found. There's various command lines people have executed here, and you can see what they've been doing. And similarly, in the hash dump section, you can find password hashes. And there they are. These are the Microsoft Windows stored passwords. You see, this is what they look like. So passwords are stored in this cryptographic hashed form, and you can crack them by Googling them or running hash cracking tools on them. If the password is not too long and complicated, you can recover the password from that. And here's image info that tells you just what version of Windows is being used and such. So there's a variety of flags to find here. LSA reveals the default administrator password. It's one called Local Security Authority. NetScan shows you information about network connections on this machine at the time the memory was imaged. Here you get a list of running processes. So you see all the executables that are running, like Notepad was running and other things like Adobe ARM. And then there's shell bags, which shows shared, among other things, shared folders it connected to. It connected to some shared folders here, and you can get the name of a share on another machine. So that's, and then there's user assist, which gives you the name of an executable that ran at a certain time. This records when things were launched. So that's all information, and then you can crack a hash for extra credit if you want to use a hash cracking tool. Well, for these passwords, you can probably just Google the hash. Would probably work. For relatively common passwords, people have just stored the cracks online. So anyway, yeah.
So all of this data came from the RAM?
Yes. The RAM has images of everything that's currently running on the machine. All this came from the RAM. And that's why if you image the hard drive, you don't get any of this. That's why live acquisition is considered much more valuable than static acquisition, where you just image the hard drive. Especially for incident response. Yeah. Oh, I thought you said something. All right, let me stop this recording.